So what else can we do with vectors? Well, another thing that I'm sure you know how to do with vectors is to add them or to scale them. So vector addition. So if you have two vectors, A and B, then you can form their sum A plus B. How do we do that? Well, first, I should tell you, vectors, they have this double life. They're at the same time geometric objects that we can draw like this on pictures, and they are also computational objects that we can represent by numbers. So every question about vectors will have two answers, one geometric and one numerical. Okay, so let's start with the geometry. So let's say that I have two vectors, A and B, given to me. And let's say that I thought of drawing them at the same place to start with. Well, to take their sum, what I should do is actually move B so that it starts at the end of A, at the head of A. Okay, so this is again vector B. So observe, this actually forms now a parallelogram, right? So this side is again vector A. And now, if we take the diagonal of that parallelogram, this is what we call A plus B. Okay, so the idea being that to move along A plus B, it's the same as to move first along A and then along B. Or along B, then along A. A plus B equals B plus A. Okay, now if we do it numerically, then all you do is you just add the first component of A with the first component of B, the second with the second, and the third with the third. Okay, say that A was A1, A2, A3, B was B1, B2, B3, then you just add this way. Okay, so it's pretty straightforward. So, for example, I said that my vector over there, its components are 3, 2, 1, but I also wrote it as 3 times I plus 2 times j plus k. What does that mean? Oh, so I need to tell you first about multiplying by a scalar. So maybe I should say this is about addition. So multiplication by a scalar, it's very easy. If you have a vector A, then you can form a vector 2A just by making it go twice as far in the same direction. Okay? Or we can make half A more modestly. Or we can even make minus A, and so on. Okay? So now you see if I do the calculation 3 times I plus 2 times j plus k, well, what does it mean? 3 times I is just going to go along the x-axis, but by distance of 3 instead of 1. And then 2 times j goes 2 units along the y-axis, and k goes up by 1 unit. Well, if you add these together, you will go from the origin, then along the x-axis, then parallel to the y-axis, and then up. And you will end up, indeed, at the end point of the vector A. OK. Any questions at this point? Yes?
So for the geometric vector addition, you're basically just using the tip-to-tail addition?
Exactly. To add vectors geometrically, you just put the head of the first vector and the tail of the second vector in the same place, and then it's head-to-tail addition. Any other questions? Yes?
So when you're subtracting, you just put one in the other direction?
That's correct. If you subtract two vectors, that just means you add the opposite of a vector. So for example, if I wanted to do A minus B, I would first go along A and then along minus B, which would take me somewhere over there. OK? So A minus B, if you want, would go from here to here. OK. So, well, hopefully you've kind of seen that stuff either before in your lives or at least yesterday. So I'm going to use that as an excuse to move quickly forward. But